Alright, welcome back, Chemistry B. This is Unit 6, States of Matter and the Gas Laws. This is Day 4. We're going to talk about a phase change called sublimation, and we're going to take a look at phase diagrams. Okay? First of all, we're going to talk about sublimation. And sublimation is a phase change which is different than the other phase changes. As you remember, some of the phase changes that we've talked about and you've learned about in the past are freezing and condensation and vaporization and melting and freezing. Well, we're going to talk about a phase change today where we skip going from one phase to the next phase. Now remember, phases are solids, liquids, and gases. Oh my. So in other words, when you take a piece of ice and you put it into a pot and turn the heat up, it goes from one phase change to another. And if you leave that ice on the stove for long enough, it will go from one phase change, solid, to a liquid, and then it eventually will vaporize into a gas. And it will be what we appear to be gone. But if it went from a solid as an ice cube to gas by going through the liquid stage. Sublimation skips that gas stage, okay? Or excuse me, that solid, that liquid stage. So a change of a substance from a solid to a vapor, which is also another word for gas, without passing through the liquid state. All right, it takes place in solids that have vapor pressure higher than atmospheric pressure at or near room temperature. Okay. Dry ice is the most famous example that we can look at dealing with sublimation. Dry ice is the granddaddy of them all. Okay. Examples. Another example of sublimation is iodine undergoing sublimation. All right. Now, with dry ice, as you know, it is extremely cold. It is dangerous to touch with just your hand, so you have to handle it with heat gloves. And if left out for a day or so, it will, or if left out exposed to the air, regular room air pressure, it will go from a solid to a gas. Regular ice, as you know, would melt, and it would have a liquid. So they use dry ice to ship foods, frozen foods across the country so that it stays fresh, because it does not leave that liquid as it melts, it just turns into a gas. All right. The uses of sublimation are some freeze-dried coffee. We will freeze-dry coffee using sublimation. Your solid air fresheners are sublimation. As you know, you open those up, and they over time they look like they have disappeared. Well, it's not that they've disappeared; they've just turned into a gas. And we can use sublimation to separate mixtures. Okay. Let's switch gears and talk about changes. Phase change diagrams. All right. Phase change diagrams is a graph which will show the relationships among the three phases of a substance in a sealed container. Now, the line on the phase change diagram indicates the conditions of pressure and temperature at which two phases exist in equilibrium. Okay. Now, if you don't remember what equilibrium is, I suggest you go back to Day 1 or Day 2 notes and refresh on equilibrium so that you understand what we're talking about here. All right. The line on the diagram, and you're going to see this line in just a second or two, will separate the phases. The point on the diagram where all three phases can exist in equilibrium with one another is called the triple point. All right. Water has a triple point, and it takes place at a temperature of 0.016 and a pressure of 0.61 kilopascals. All right, and remember, standard temperature and pressure is 25 degrees Celsius and 103 kilopascals. So it's 101.3 kilopascals, excuse me. Obviously, this water's triple point is very, very far away from normal. All right, and here is this phase change diagram. All right, here you see 0.61. That is pressure on the left. Down here is temperature. Okay, and here's the triple point, which we just talked about. Now, normal melting point of a solid takes place at 101.3. Now, this is of water, so that would be ice over here. This is all ice. And at 101.3 and the temperature of 0 degrees, we start melting. And normal boiling point is 100 degrees Celsius at 101.3 kilopascals. Green is liquid, the yellow is the vapor, gas stage, and solid is blue. Now, right in here is where we go, which will demonstrate the area of which sublimation takes place. Remember, that's a solid going to a vapor, and this takes place at extremely low temperatures. Okay, so when they make dry ice, they make it down here where temperature is extremely low and there's extremely condensed vapor and pressure, high pressure system, and then it will eventually turn into a vapor over time. Okay, so liquids or regular water will go from a solid to a liquid to a vapor, or from a vapor to a liquid to a solid, but with sublimation, that's from going from a solid to a vapor with skipping this liquid stage. Okay, all right, and that's all for today.